Hello guys, welcome back to my channel. My name is Ken Carty. Please remember to like and subscribe. Today we'll be looking at what is called a probability tree. Now a probability tree is a statistical diagram or a sample space diagram that uses a branch-like structure to display probability and all possible outcomes of a random experiment. Now here's a typical example. A bag contains 5 blue marbles and 4 green marbles. 2 marbles are drawn at random. Draw a probability tree to show all possible outcomes. Now, before we start drawing our probability tree, there's a conceptual idea that we need to explain in probability. When you draw 2 marbles at once, it is the same as drawing 2 marbles simultaneously, or should I probably say similar. The results or the outcomes will be the same. So we can break this down by looking at what happens in the first draw and then what happens in the second draw. And the probability tree or the branches are what are used to show this outcome. So let us start our probability tree. First thing we're going to have here is B to represent the event that a blue marble is drawn. All right, so we'll actually write that out as the event that a blue marble is drawn, and G, the event that a green marble is drawn. All right, so you can have that. You can create a key, put it somewhere. So the first time I draw a marble, the first time I put my hand in the bag to draw a marble. So let us think of us drawing the first marble. What is the possibility? You're drawing a single marble. So we can either come up with a blue marble or we can come up with a green marble. The probability will go on the branches. Now, what is the probability that I'm going to draw a blue marble? I have 5 blue marbles and I have 4 green marbles, which means in all I have 9 marbles. So the probability of drawing a blue marble would be 5 out of 9. We have 4 green, so the probability of drawing a green on the first attempt would be 4 out of 9. So we can call this the first draw. Now, when I'm going to make my second draw, if my first marble was blue, on my second draw, I could get blue again, or I could get green. But if my first marble was green, on my second draw, I could get also blue again, or I could get green. Now, before we go any further, one of the things that we want you to look at is go back to the first draw and look at the probability of getting a blue or getting a green. You have 5 over 9 for blue and you have 4 over 9 for green. If you add those together, you're going to notice you're going to end up with 9 over 9, which is equal to 1. Now, let's proceed with our branches. So this is my second draw. Now, what if the first marble was blue? I would have 1 less blue marble in the bag and also 1 less marble overall. So the probability of drawing a blue on the second, if the first was blue, would now be down to 4 out of 8. What about drawing a green second if blue was first? If you draw blue first, it means you still have all of your green marbles, but you still have 1 less marble, which means the probability of drawing a green marble if the first marble was blue would now be 4 out of 8. All right. Now we're going to look at drawing your second marbles when the first marble is green. So we're doing to the second set of branches here. If the first marble is green, it means that you still have all your blue marbles. So I'm going to have 5 here. But I will have 1 less marble as I would have taken out a green marble, so it's 5 out of 8. But if the first marble was green, drawing a greens next would be I would have 1 less green marble. So this would come down to 3. If the first was green, this would be 3 out of 8. Now let us look at all the pair of branches. Notice for the second draw, for the first 2 branches, which are blue and green, if you add those, you also get 1. So each pair of branch would give you a sum of 1. We can now look at what we call our outcomes. So my outcome would be, we can get blue and blue if we follow the branches. So blue then blue. We can get blue then green. So blue then green. So if the first was green, we could get green then blue, or we could get green then green. So this shows you all the permutations of the outcomes when this is done. So how do I get the probabilities of the outcomes? Now if you go back to my video on conditional probability, you will see how we actually transpose to get the probability of A and B in a scenario like this. So it means that I would have to multiply the probability of blue on the first, which would be 5 over 9, times the probability of blue on the second, which would be 4 over 8. And we will do that for all the branches. So for getting blue and green, I would have 5 over 9 times 4 over 8. The green and blue would be 4 over 9 times 5 over 8. And green would be 4 over 9 times 3 over 8. Now you don't actually have to work out all that there. What you can simply do is use your calculator, work out the results, and simply fill in the probabilities underneath the probability section there. So what I did is that I went ahead and worked out the probabilities. Now if you look at the probabilities coming down, the last one I could have broken down to 1/6, but I deliberately didn't break it down because I want to show you that when you add the numerators, since all the denominators are 18, we add 5 plus 5 plus 3, we actually get 18. So the probability of your sample space is equal to 1. So when you add up all your probabilities, you should always get 1. Now let us look at some of the questions we could actually ask you in a scenario like this. So what if I ask you what's the probability of getting 2 green marbles? You go back to your probability tree, look at your outcomes. Getting 2 green marbles would be the same thing as saying, well, so we could say this is equivalent to the probability of green, which would actually give me 3 over 18, which I can break down to 1 over 6. So that is the probability of getting 2 green marbles. Now, what about the probability of getting 1 blue marbles? 1 blue marble, sorry. I would have to go to my outcomes. Look at the scenarios where I have 1 blue. So this would be the probability of blue-green. And of course, these events now, these outcomes are mutually exclusive because they can't happen at the same time. So it's the probability of blue-green plus the probability of green-blue. Now the probability of blue-green here is actually 5 out of 18. And the probability of getting green-blue is also 5 out of 18. Which if we were to break this down, we would end up with 10 over 18, and in its simplest form, that would be 5 over 9.